All right, which triangle is not similar? Once again, we're asking the not question, not similar to any of the others. So that means 3 out of 4 are similar. Okay, so which one is not similar? So let me just go ahead and find the angle measures for all all 4 A, B, C, and D triangles. So here I don't know what this angle is, so let me find it. 50 plus 80 plus, let's just call it x. Okay, it doesn't really matter what you call it. Let's just call it x equals 180. I do know the sum of all 3 angles in each triangle here. Each triangle equals 180. 50 plus 80 is 130 plus x equals 180 minus 130 minus 130. I should get x equals 50 degrees. X equals 50. So this is a 50 by 50 by 80 triangle as far as the angles go. All right, letter B. Remember, once again, this little box symbol means 90 degrees. Okay, so don't forget that. That's 90 degrees. Let me do it in red or purple. Red, we'll do red. In 90 degrees. Okay, the box means 90 degrees is a right angle. 60, unknown. 60 plus 90 plus, let's call this one y, plus y equals 180 degrees. 60 plus 90 gives me 150 plus y equals 180. Subtract 150. Subtract 150. And I get y equals 30 degrees. So this one is a 30, 60, 90 triangle. 30, 60, 90. Okay, so obviously these two are not similar to each other. So the answer is either going to be A or B. It's got to be one of these two. Here I see 30. Here I see 90. 30 with 90. So this one's got to be 60. This one. Here I see 30, 60. So I'm guessing this one's also 90. So the answer's got to be A. It's the only one that's not similar. Everything else is a 30, 60, 90 triangle. Question number, I guess this must be 17. In the figure below, lines AB and CD are parallel. Measure angle 3 is 50 degrees. Okay, so the measure of angle 3 is 50 degrees. Find the measures of angle 1, 5, and 6. All right, angle 3, 50 degrees. Angle 1, ask for the measure of angle 1. Now, right here, 90-degree symbol. It's got to be 90 degrees. Your explanation, it is marked by the 90-degree symbol, box, something along those lines. Something that shows me that you know that this little thing right here shows me that's 90 degrees. Okay? All right. Angle 5, the measure of angle 5. Now, I know that AB and CD are parallel. So if I cover up this line, don't even think about this line right here, I see that angle 5 and angle 3 are corresponding angles. Okay? So if you're looking at this parallel line, this transversal right here, and these parallel lines, oof, that's bad. It's hard for me to draw very straight lines with this thing, and I apologize. But hopefully you're getting the idea. So AB, and DC, AB and DC. If you look just at the red and don't look at the black at all, you see that angle 3 and angle 5 are corresponding angles. They're both on top of the line, B and D. They're both on top of AB and CD. Okay, they're both on top of it, angle 3, angle 5. They're also on the right side of this transversal. So they're on the same side, same position, which means they are congruent to each other. So this angle 5 is 50 degrees as well, because angle 5 corresponds to angle 3. They are corresponding angles, therefore they are congruent. Finally, angle 6 says 90 degrees is angle 1, 50 degrees is angle 6. So how you're going to show me that what angle 6 is that you know the sum of all 3 angles in a triangle equals 180. So you know one is 50 degrees, the other is 90 degrees, and the other is angle 6. We don't know what it is yet. And that equals 180 degrees. So you just simply solve this. 50 plus 90 is 140 plus angle 6 equals 180. So subtract 140 minus 140, and you get angle 6 equals 40 degrees. Now that's enough of an explanation right there. I would accept that mathematical work shown to be an explanation, but if you want to say something along the lines of all three angles in a triangle add up to 180 degrees, that would also be a good thing to write down.